Yeah, hello everyone. Today we are going to solve Leetcode problem number 1601, maximum number of achievable transfer requests. So first read out the problem and then I will explain what the problem statement is saying. So the problem statement is as we have n buildings number from 0 to n minus 1. Each building has a number of employees. It transfers even. And some employees want to change the building they reside in. You are given an array request where request I request from to two represents an employee request to transfer from to building two. All buildings are full, so list of requests is achievable only if for each building the net change in the employees transfer is zero. This means the number of employees leaving equal to the number of employees moving. For example, if n equal to 3 and two employees are leaving the building, one is leaving building 1 and one is leaving building 2, there should be two employees moving to building 0. One employee is moving to 1 and one employee moving to 2. So we have to return the maximum number of achievable requests. So the problem statement is a little bit messy, so I will explain you the problem statement via an example. So let's take this example to the board. So let me just copy it from here. So I think there is a problem. Wait a minute. Let me again take it from here and then I will explain this for the problem statement. So actually, it is saying that we have given these buildings and this is the transfer season going on in the company. So uh, some employees want to transfer from one building to another building, and the transfer is only possible when some employees from the other buildings want to come and go in some other building, then you can only transfer to that building only. And the employee position left here after some employee gone to another building will filled by some another one because basically the term they say is what net change I think. Yeah, net change. The net change is zero. So let me explain the example. So from here, two persons leave this building zero. They so minus one, and two persons join this building. So plus two. Same for this building. Two persons join this building. So here we have different plus two, and two persons leave this building. So here minus two. Here one person join the building and one person leave the building. I and for this one person leave the building and one person join the building. So what here? What I mean that plus one and minus one equal to zero. So this means that the net change of the transfer rate is zero for this building. And same for here, plus one minus one is zero, plus one minus one is zero. So for these group of buildings, the net change is zero. And for this, here minus one and basically this is not zero, right? Someone is going from this building and no one is coming into this. So the net change is not zero. So this is like not a balanced net change. So we will not include this. So what we have to return the number of maximum request which we can handle. So the which is called the request. We call request this like these requests this transfer request. So in this case, the first request is this, second, third, fourth, and fifth. So our final answer is five for this question. So let's see how we can solve this problem. So let's see at the constraint. The constraint are very low. Like the request we are getting is maximum of like 16 length. So what we can do as the test cases are very low. So what we can do in this case, we can use a brute force kind of solution and that will surely get a AC. So what we can do, like let's see how we are getting the request input. So basically we are getting the input in this format. Let's put it to the board too. And then So basically, what this means from employee from zero building want to go to the one building. So what we can do, we can generate all possible ways employees can mm, exchange their positions basically. So we will generate all the subsequence of this array which given and see which array gives us maximum answer. So suppose the first because we will choose based on this request and then count how many numbers we are getting, like how many requests we are able to handle by satisfying the next condition. So basically, we will generate all the possible subsequence, so we can use backtracking of a kind of solution. So for this, like for this array, its size is 1, 2, 3, 4, 6. So the most like worst case point complexity will be to the power 6 as the like generating subsequence will take exponential time kind of complexity and the maximum length of the array can be 16. So the worst case complexity for the worst case will be 2 to the power 16 which will easily get as accepted. So we will just use the brute force solution. So let me explain what the brute force solution will be and how it looks like. So let me explain you code I have already written in the code editor. So what I have did, I have made helper function. So what basically it does, it like we for every request we have two choices, right? Either we can like process this request or we will not process the request. For every request we have two choices. So what we will do, we have written here like we will not choose this request and we will choose this request. Yeah. So basically, we have choose the request. So if we do not choose the request, then we do not have to do nothing. Then what we will do, we will simply make sure index without doing anything. But if we choose an index, so we have to do some kind of task, right? So we have to pre-process our result. So what we will do, we will take an basically in degree of degree kind of array. So what we were doing as we were what doing what? Yeah, for like 2% and going, so we are incrementing it and 2% are coming, so we are decrementing it. So this will, so we will do same for this case in this in degree array, so that we can compute it later and store the results. What we will do, like the this value is expecting in this variable, and the second value we are extending this variable. So basically it denotes that from this current zeroth, like from building we are going to a tooth building. So we are going from building. That's why we are decrementing its size, and we are like going through the uh, like tooth building basically a tooth building. So we are implementing its size and then we are processing it. Mm, because we have taken this request, we have choose this request, so we have increased the size of this request so that in the end we store the answer. And it's like we have to try this for all requests. So if, once we process this request, we will undo all the changes. So first we have decremented it, and later we will restore it. It's in original position. So basically, we are like this kind of backtrack. We are backtracking it. So what will be the base condition when our index reaches to the end of this request array? What we will do, we will try to check if any like any element size in this array is not equal to zero. That then we will know that the next change is not zero. So we are not satisfying the condition. So simply we will return from this and we will not save any kind of result. But if all the elements are zero, then we will know that this is satisfying your net change condition. So we have maintain a global variable answer where we will simply store the best answer which for us. So we'll compare request and the existing answer. The answer which will maximum will be stored in this, and that's the solution for this. I think we have got this solution. This is a totally like easy kind of problem. Thank you.